This is the Inscribed Angles tutorial. Let's begin this tutorial with an illustration of what an inscribed angle is. An inscribed angle is any angle whose vertex lies on a circle and whose sides contain chords of the circle. Now remember that a chord is just a segment drawn within a circle whose endpoints lie on the circle. For example, HK here is a chord in this circle, and it also has HL here, which is a chord. So these two chords together making an angle here, angle KHL, creates an inscribed angle, this angle inside the circle whose vertex is on the circle. I've drawn a couple more examples of inscribed angles here. We've got this purple one here, which is angle MIO, and we've got this other inscribed angle in green here, which is JPN, or NPJ, however you prefer to say it. Now remember, they're all considered inscribed angles because they're chords whose vertex lies on the side of a circle. Another important thing to mention is that inscribed angles that are either subtended by the same chord or intercept the same arc are congruent. Now what does it mean to say subtended? Well, basically, if the endpoints of a chord or arc lie on the sides of an angle, then that chord or arc subtends that angle. For example, let's look back at that original angle, angle KHL. Now, this part of the arc right here, this arc KL, is referred to as subtending angle KHL. So arc KL subtends angle KHL. Now, if we had a chord drawn from K to L right here, then that chord KL, would subtend angle KHL. Now the same is true if we were looking at the green angle, angle JPN, and we had drawn a chord from J down to N. That chord right there, chord JN, would be considered to subtend angle JPN. And also, this arc right here, as another example, arc O to M here, is going to subtend that purple angle, angle MIO. So that's what we refer to with subtending angles. So remember that note, that inscribed angles that are either subtended by the same chord or intercept the same arc are congruent. And I'll give you an actual example here. I'm going to draw in another angle on this diagram. Alright, you can see my new angle in red here, angle KPL. Now notice that KPL and KHL both subtend arc KL. Since both subtend arc KL, that must mean that angle KHL, the orange angle here, is congruent to angle KPL. And you can even see that they look congruent. And also, if we had a chord drawn in here again from K to L, because both of those angles would be subtending arc KL and subtending chord KL, then they would both be congruent as well. KHL would be congruent to KPL because they both subtend chord KL, that chord that we just drew in here. Alright, let me give you another example. Let's say that in this example, we have angle 1 and angle 2, and I'm just going to abbreviate angle 1 here. We'll call it points A, B, and C. And this point for angle 2 at the vertex of that inscribed angle 2, I'll call that D. Now what can you tell me about angle 1 and angle 2? Well, you notice that they both have this arc congruent to each other, arc BC. Which means that they both subtend, that arc subtends both angles. Which means that both angles 1 and 2 must be congruent to each other. So you could draw that in here. Angle 2 is congruent to angle 1. Alright, now let's move on to an important piece of information regarding semicircles. If an inscribed angle subtends a semicircle, then it must be a right angle. So for example, here's our inscribed angle, angle XZY. And because it subtends a semicircle, and you know it's a semicircle that we're referring to here, because XY is a diameter, which means that this must be half the circle. So it's a semicircle. And that angle that inscribed angle there, xzy, is subtending that semicircle, which makes it a 90-degree right angle. Now lastly, let's take a look at what happens when you inscribe a quadrilateral inside of a circle. When a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So in this case, we have quadrilateral WXYZ. Now W and Y must be supplementary, and X and Z must be supplementary. Now remember, supplementary means that they add up to be 180 degrees together. So let's take a look at an example problem. What if I told you that angle W was 47 degrees and angle X was 102 degrees? Could you solve for angles Y and Z? Well, yeah, because you know that W and Y are supplementary, so they add up to 180 degrees, and X and Z are supplementary, so they too add up to 180 degrees. So angle W plus angle Y is equal to 180 degrees. And we know that angle W is 47 degrees. So plus angle Y here must equal 180. So I'll subtract 47 from both sides of the equation, and angle Y is equal to 133 degrees. And we can do the same thing for Z. Angle X plus angle Z must add up to 180 degrees because they're supplementary. And we know that angle X is 102 degrees. So we can subtract 102 from both sides of the equation, and what we get is angle Z is equal to 78 degrees. Now remember, this is true for all quadrilaterals that are inscribed in a circle. Their opposite angles will always be supplementary.